All right, this is part 2 of the midterm review, the practice test. I'm starting with number 9 here. This is a radical equation that has 2 radicals to solve, so we have to be a little bit more diligent with this type. So when you're doing a radical equation, you're going to use something called the power rule, and it means that you're going to isolate a radical on a single side by itself. You'll raise both sides of the equation to whatever that root is. So if it's a square root, we'll square both sides. If it's a cubed root, we'll cube both sides. You will then work out the resultant equation, which is not the original equation, by the way. This is what we call a similar equation. You'll solve it as long as you have no more radicals, and you will get an answer. But unfortunately, it doesn't always work in the original equation. For example, if you square a -4 and you square a +4, they both equal 16. But they were not equal to each other originally. So this is the problem where we have to check our solutions because there can be extraneous solutions. So I'm going to isolate this first radical on the left by moving the other radical over. Now, unfortunately, when you have 2 radicals, you must do the whole process twice to get rid of both radicals completely. So if I move this over, I would add that whole term over. So plus the square root of x minus 3. Now that it looks nice, it's got this radical over here isolated, I will square both sides to get rid of the 5x plus 1 square root. So this square and square root cancel out, but we have this nasty situation on the right. You cannot just square both numbers here. There's a plus sign between them that is illegal. The rule only works if it's multiplication between the two things. So if you have a binomial, which is anything separated by adding or subtracting where you have 2 separate terms, you're going to have to write this twice and FOIL it. That's the only way that this will work out correctly. Now, when we FOIL with radicals, we do need to be cautious. This is going to be 5x plus 1. This is a long problem, so I may have to write and then erase. We'll just have to see. 4 times 4 is 16. 4 times the square root of x plus 3 would be 4 on the square root of x plus 3, or x minus 3. You cannot distribute that. It's a radical and a non-radical. You get another 4 on the square root of x minus 3 from the next foiling step. And then square root times square root when the inside is the same is the square root of the number squared. So you just get the inside. So saying square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. So we just get that interior. We want to do some combining of like terms before we move on. So we have 5x plus 1. 16 minus 3. You can't do anything with the 4's because they're connected to the square root right now. 16 minus 3 is 13. I also have my plus x that's not in a radical, and I usually put my radical at the very end. So this is an 8 because it can add those like radicals on the square root of x minus 3. You'll then want to move everything else to the other side. Try to get this radical isolated because we do still need to get rid of it. So 5x minus 1x would be 4x. 1 minus 13 would be negative 12 equals 8 square root of x minus 3. And the goal is to isolate the radical, but if you divide by 8, you're going to create a bunch of fractions, but they are all at least divisible by 4. So I can at least on the outside numbers make it smaller. Sometimes I won't do anything and I'll just FOIL with it as it is. It just depends on if it's going to work nicely. I try not to create the fractions if I don't need them because we can square this whole term since they're connected by times. So if I divided everything by 4, I get a x minus 3 equals a 2 on the square root of x minus 3. Now we're going to square both sides to get rid of this last radical, taking care that we are squaring a multiplication combo on the right side. So this is x minus 3 because it's a binomial times another x minus 3. We do have to do both of those. On this side, you square both pieces since they're connected by times. So that would be a 4. And then you do want to write this in parentheses. You square this and it cancels and just leaves me with x minus 3. So we're finally at a point where we don't have any radicals left. So we need to FOIL this out. So this is x squared minus 3x, and minus 3x would be minus 6x, just because I'm running out of room. Negative 3 times negative 3 is positive 9. 4 times x is 4x. 4 times negative 3 is negative 12. When you have a quadratic, you usually want to move everything to one side so that you can try and factor. So we need to subtract over the 4, which makes this negative 10x, add the 12 to 9, which would be 21, and then it equals 0. We can try and factor this trinomial that leads with a 1. We need factors of 21 that add to negative 10. So x minus 3 and x minus 7. Set both of those equal to 0. We have two possibilities. The first factor would be 0 if we put in a 3. The second factor would be 0 if we put in a 7. So those are the two possibilities for our solutions. They're not guaranteed. You need to plug them back into the original and show that they are actually equal. So I'm going to do it right here. So if I plug in 3, that'd be 15 plus 1 under this radical, and that would just be 3 minus 3. So that is square root of 16 minus square root of 0 equals 4. Square root of 16 is 4. 0's square root is 0, so 4 minus 4 does equal 4. Now if we want to plug in 7, that'd be 5 times 7 plus 1, so that's square root of 36, running out a little bit of room. 7 minus 3 is 4. So square root of 36 is 6. Square root of 4 is 2. 6 minus 2 is 4. So in this case, both solutions do work. And this says simplify your answer, which we did. Use a comma to separate the answers as needed. This is not an ordered pair, it's a set of solutions. So in this specific one, both answers worked. We might give you one where one works and one doesn't, or they both fail. So you do have to do the check. Okay, so this next one says find the real solutions, if any, for the following equation. Use any method you would like. Since it's quadratic, you could use quadratic formula here. You can always check to see if something factors. When you have a non-1 up front, the best way to factor is something called the AC, or factor by grouping method. And this is just because it's a set of procedures. You could do trial and check if you want. You multiply the leading coefficient times the constant, and that gives me negative 400. And then we list factors of 400. So 1 and 400, 2 and 200. You'd want to check and see if 3 goes into it. To do a check, you just take the number, divide it by the number you're checking. If you get a decimal, it doesn't go evenly. We know 4 and 100. And we know it ends in a 0, so it should be divisible by 5. And you think, how do I keep going? How long do I have to go? Well, until the numbers are so close together that nothing in between them works, or until you already find the pair that works, you keep going. Is 400 divisible by 6? It shouldn't be, because 2 and 3 didn't both work, so C, no. Is it divisible by 7? Nope. Is it divisible by 8? Yes, it should be. 8 and 50. It's just the kind of swap of these two. Is it divisible by 9? Too many numbers. Nope. 10 is 10 and 40. So see how the numbers keep getting closer together. 400 is not divisible by 11, I'm pretty sure. Is it divisible by 12 is the next question. Nope. Is it divisible by 13? No. Is it divisible by 14? Nope. So see, I'm just going through my list, working my way up. 15, no. 16, yes. 16 and 25, and I believe that might be our pair, but just to show you how you can finish this off, I'm going to keep going. 17 doesn't work. 18 doesn't work, I don't believe. 19 does not work. And 20 times 20 is the last one. Now we know that's the end because there's no number between 20 and itself. So that would be a complete list of factors. So if you ever have an AC method, this is how you exhaust your list. Now this is a negative 400, so we need opposite signs, and it needs to add to negative 9. That's why I knew it was 16 and 25, and it's going to be a negative 25 and a positive 16. So your next step when you're factoring by grouping is to change this from 3 terms to 4. And you can put 25 or 16 first, either one you want, but they both have to have the x that was on the negative 9. So I'm going to put negative 25x plus 16x minus the 20. So notice the first term and the last term did not change at all. We split the middle. Then we do factoring by pairs. The first pair have a 5 and an x in common, which means that would leave me with 4x minus 5. Whatever the sign is on the second pairing, you have to pull that out, whether it's plus or minus, and then you ask what they have in common, which looks like a 4. That would also leave me with 4x minus 5 equals 0. The whole goal of factor by grouping is to get a matching binomial. That comes to the front as a single GCF. This is me pulling 4x minus 5 out of both of those. and then the leftovers in front become the second binomial of your factor. Then we set each of these equal to 0 to solve. I'll do one of them, and then the other one will be pretty apparent. You add 5 over and divide by 4. Sorry, my pen is too much ink. It has to think sometimes. So 4x equals 5, x equals 5/4. So one of the solutions is 5/4. This one would be subtract 4 and divide by 5. So negative 4/5, comma, 5/4. Type in exact answers, not decimals, radicals if needed, commas to separate as needed. Okay, so then that gets us to number 11, which I believe will probably also be a factoring situation for us. This is already set up as 4 terms, so we need to try to factor by grouping. I can pull an x squared out of the first pair. That leaves me with x minus 6. The second pair leads with a negative, so I'm going to pull that out, and they're both divisible by 36. That also leaves me with x minus 6. If you do your calculator, 216 divided by 36 is 6, and it's negative because we pulled our sign out, so it flips that plus to a minus. The x minus 6 is a match. That leaves me with x squared minus 36 as the leftovers. This time this factors again because it's a difference of 2 perfect squares. So if I factor it again, I get an x minus 6 and an x plus 6. So one of the x minus 6's is from the original factoring. The other is from this separate factoring. So this looks like my solutions are negative 6 for the x plus 6 and a positive 6. And we had what we call a multiplicity. At the x minus 6, which we gave us that was the factor that gave us x equals 6, your answer occurs twice. So that's a multiplicity of 2, which we do talk about when we graph polynomial functions. Okay, so let's look at number 12. This looks like it's plugging into some formulas and working on some stuff. So it says, suppose that the revenue R in dollars from selling X cell phones in hundreds is R of X equals negative 1.1 X squared plus 290X. The cost C in dollars from selling X cell phones, it's hard to speak, in hundreds is 0.05 X cubed minus 3X squared plus 70X plus 700. Find the profit function. Now it tells you what to do. You do revenue. So I'm going to put this in a parentheses since there's multiple terms. So revenue function, which is this, minus cost function, which is this. Now what I see usually when students miss this one on the test, it's because they are careless with distributing their negative. This first guy, there's not really anything going on, so yeah, technically you can drop the parentheses. There's nothing in front of it but a positive 1. This is a negative, so you have to distribute that negative sign, and that will change every sign in this second function. So if we combine like terms, first of all, the x cubed is the highest power, so this is negative 0.05 x cubed. For the x squareds, we have a negative 1.1 and a 3. So if we add that together, that would be 1.9, and it's positive. X squared. For the x's, it's 290x minus 270, so that'll be positive 220. And for the constant, it looks like all we have is the minus 700. So that is our profit function. Now, once you've got that, this just says plug 12 into your profit function. So this can be tricky, especially if you don't use parentheses correctly on your calculator. And I'm not 100% sure that this calculator can handle it because this is not a really fancy calculator. It is pretty bare minimum. So I have my negative times parentheses 12. Then we want to cube that. Notice I'm putting things in parentheses as needed. Plus, and sometimes I'll put the terms in. If you're using a really interesting calculator, I sometimes use multiple parentheses, like around a whole term, just because I have seen the calculators do weird things. And I don't want you to miss that on your test. Then we close that parentheses, so that's term 2. Plus term 3 is 220 times 12. minus 700, which is a single term. So if we've done everything correctly, we should get the answer of 21227.2. They ask us to round that to the nearest cent, so you actually do need to add a 0 because nearest cent means the hundredths place. So that's a 0 since it's not there. Now interpret P of 12. Choose the correct answer below. So this says when 12 cell phones are sold, the cost is given by P of 12, the revenue or the profit. Well, this was the profit function, so the answer to that is C. There we go. Okay, so let's move on to number 13. It says find the domain of the function. When you're dealing with functions, domain has to do with whether or not you can plug something in, essentially, to your function and still get a real number answer. So when we're dealing with square roots, we don't want to plug in anything that makes it negative under the radical, because that would be that imaginary I unit. The little I that we pull out when we deal with imaginary numbers or complex numbers. So essentially, this is forcing us to keep the inside of the radical. This is because we want to keep this something real, either 0 or bigger, because 0 is okay, because square root of 0 is just 0. That is a real number. So anytime you're dealing with a square root, you set the inside of the radical greater than or equal to 0 and solve to find your domain. So this would be x is greater than or equal to 6. And we would write that in interval notation, which is a bracket saying we are including the 6, and then we shade to the right, so shading towards positive infinity. You never use brackets on infinity. Those are not really numbers. It's an idea or a concept, so it's kind of an open-ended, never can reach it and include it. Okay, that leads us to number 14. The length of a rectangle is 4 meters less than twice its width. If its area is 240 square meters, find the dimensions. Okay, so we're going to draw a picture because that's always useful. The length is this part down here. This is the width. So it says the length is 4 meters less than twice the width. So somebody doubled our width, and then less than means subtracted 4 from it. Now that's important because area of a rectangle is length times width. So 240 is my area. My length is 2w minus 4 because we want to use the w's so that they match, and my width is w. So I'm going to distribute on the right side, so that'd be 2w squared minus 4w. We can get everything together by subtracting that 240. So it's going to be 0 equals 2w squared minus 4w minus 240. Divide everything by 2 since everything's even on both sides. 0 divided by anything is still 0, as long as the bottom's not 0. This would be w squared minus 2w minus 120. If the pen can catch up. It does not want to. No. Well, that's not fun. Let's try something over here. Nope, it's completely frozen. Okay, I'm going to pause the video real quick and try to reopen the PDF and see if that fixes it, and then we'll continue on this problem. Okay, I had to rewrite it real quick. So this is going to factor into factors of negative 120, so that's different signs. Since this leads with a 1, we don't need to do the AC method. So just factors of this that make negative 2 when you add them, and they have different signs, would have to be negative 12 and 10 for my two factors, and 10 is positive. So that would be w equals 12 when we solve, and w equals negative 10. Now negative 10 does not make sense for the width because that would be negative measurement. So that means the width has to be 12 meters. And if you plug in, you can find your width. So this is 24 minus 4. So that's going to be 20 for the length. So 12 for the meters for the width, 20 meters for the length. Okay, so that means we're moving on to number 15. So it says answer the question about the following function. We say that we have the function x plus 4 over x minus 12. First question is the point 3 comma negative 11/5 on the graph? So to test that, you just need to plug 3 in. So 3 plus 4 over 3 minus 12 is 7 over negative 9. So that is not true. This should have been a negative 7/9. So that means that that point is not on the graph. And I can't read the rest of this. I think it just says it does not result in it. So my answer key said that A was the one that matched that. Sorry, my graph, for some reason, when I printed these, it sometimes cuts off the far right side. So because substituting x into 3 gives the equation, given the equation does not match the negative 11 over 5. If x equals 2, what is y? Because f of x is y. So if we plug in 2 plus 4 over 2 minus 12, that is 6 over negative 10, which reduces to negative 3/5. So we would put negative 3/5 because they're just asking for the y value. So using the information, list the points on the graph of f where x equals 2. So that means we want to write it as let me read this again. So using the information in the previous step, list the points on the graph. Oh, they're just wanting us to write it as an ordered pair. So you guys, you have to really read my math lab questions very carefully because they want it as specific, and it will count it wrong if you don't type it the way they want it. Luckily, when the midterm and final are something with big high stakes, I go through, and especially if you show your scratch work and get that scanned in, I go through and check your work so that I can see if you put a period instead of a comma and you still had the right numbers. So let's talk about the next question. So if f of x, so that's saying if y equals 2, what does x? So remember, these were y. Now we're going to say what if y is 2. So that function was x plus 4 over x minus 12. So we are cross multiplying to solve this. So this would be 2x minus 24. Distribute the 2 to both things in the denominator. And in the other diagonal, we get x plus 4 times 1. So then subtract the x and add the 4 over, we get 28. So the value that gives us a y value of 2 is an x value of 28. Now be careful here. When they ask you to write this as an ordered pair, do not write 2, 28. The x was 28, the y was 2. So it is, you have to get it in the correct order. And then what is the domain of the function? Well, this function, let's write it down again just so we can see it. It has a undefined value when x equals 12. That's when the domain is not going to exist. So this would be in interval notation, everything but 12. So when we write that, we say negative infinity to the left of 12. That's why we don't use a bracket. We're not including 12. And then from 12, again, not including, to infinity. The x-intercepts. X-intercepts have to do with any factors that have an x that are still on top. So if you set that equal to 0, you get x equals negative 4. X-intercepts should be written as an ordered pair. Now, only thing is, my math lab does not like that. So if you were in my face-to-face class, I would get mad if you wrote just negative 4, but because this is how my math lab is structured, they say type it as an integer. So this is where I said, you know, sometimes I check your work, and if I see it's still right, I give you the points back on the midterm and the final. So type an integer or a simplified fraction. So the x-intercept is negative 4. To find a y-intercept, you plug in 0 for all your x's, because it's a 0 comma number. That is 4 over negative 12, which is negative 1/3. Now again, if you were in my face-to-face class, I'd want to see that ordered pair. My math lab does not type it as an integer or a simplified fraction. So they just want the y coordinate. All right, so that gets us to number 16, which will be the end. Nope. It's at the end of this one. Yes. So we're going to do number 16. And then we will stop for part 2. Okay, so determine whether the graph on the right of that is a function by using the vertical line test. If it is, use the graph to find the following: the domain and range, the intercepts, if there are any, and any symmetry with respect to the x-axis, y-axis, or origin. So this graph, to pass the vertical line test, has to have only 1 point per vertical line. Now, even though this looks like this is going to get flat, this actually continues to get closer to the y-axis, but never crosses it. And there's an infinite number of values between 0 and 1. So yes, this does pass the vertical line test. So they made this really difficult to read. So let's see. The reason this is a function is yes, because every vertical line intersects the graph in at most one point. That is what the vertical line test is. The domain and range. Okay, so go back up here. So the smallest x value ever used in this graph is -5. The graph never goes past 0. So, and both of these are open because this is an open circle and this never reaches that actual point. It's going down like an asymptote. So this would be in interval notation -5 to 0 with parentheses on both, saying not including the endpoints. Now the range has to do with the y-axis. So the highest this graph ever gets is 4, and it goes down forever. So you can imagine this going down forever. Sorry for crossing that. So that would be like -infinity. So this is -infinity up to 4. Again, you cannot include 4 because it is an open circle at that point. And infinity never has a bracket. So this part right here is just seeing if you can read the domain and range off of the picture. And then it says the X-intercept. So are there any places we cross the X-axis? Yes, and it looks like it is at -1. Again, they do not want you to write this as an ordered pair, which drives me up the wall, but I am going with how do you get your grade right? So -1 is the point where we cross the X-axis. There are no Y-intercepts. We have the Y-axis is a kind of a boundary line for us. And to be symmetric with the X-axis, you have to have the graph matching across the X-axis. It does not, because we would need it to kind of circle back and have that open circle down here. It does not have a match on the other side of the Y-axis. And to be origin symmetry, if this point is on the graph, the opposite, 5, -4, has to also be on the graph for every single point on your blue line. So again, no symmetries here, at least not anything we are looking for. Okay, so that is the end of part 2, and I will start working on part 3.